go back to the next special integral, which is the integral of this form. So I said in the last video we've done the integral of different special forms. I did the first one, which is x squared plus x squared. The next one I'll be dealing with is what? Is the integral of x squared minus x squared. That means whenever you have x squared minus a number squared. So whenever you integrate such functions, the final answer you have is this, in this form, or what? Or this form. Now, why do we have this and why do we have ln? In mathematics, the ln and the log to the base e are the same thing. Logarithm log x base e is the same as ln x. So we pronounce this as ln x, and also this is also the log x to the base e. This, so that means this represent this. They are the same thing. So in mathematics we can write ln or we write log to the base e. They are both the same. So let's get how we got to this. How do we get to this? Let's go on to that. In this type of integral, we use what we call partial fractions to solve it. So in this case, here you have the x over x squared minus a squared. That becomes 1 over x squared minus a squared dx. And in that case, I can write that as this note. This is x minus a multiplied by x plus a. They are both the same thing. This expression here is the same as this expression. So in that case, this, what I would say, can become the integral of x minus a multiplied by x plus a. And I have my dx here. From there, that becomes the integral. This is what we call a partial. So we try to what? To get the partial fractions of this. Based on the time frame of my video, I won't be solving the partial fraction of this, but I know the partial fraction of this is the same as 1 over 2a 1 over x minus a minus 1 over x plus a. This is the partial fraction of what? Of this. So this whole expression here is the same as this expression on when you do the partial fraction. And in that case, this will be 1 over 2a, the integral of 1 minus xa minus the integral of 1 x plus a. So I just brought the integral here and the x here, integral for this and the x here. Then finally my answer will be 1 over 2a. What is the integral of x minus a? That is what? Natural logarithm of x minus a. Also here, the integral of this is natural logarithm of x plus a. And from that, that should be the integral of x minus a over x plus a. Now, how did I go from here to here? Note. So I'll be cleaning this to tell you what I'm supposed to tell you before I go to that. Yeah, we know in logarithm, log of x base a minus log of y base a of the same base is equals to log of x over y base a. You divide it. So whenever you're subtracting in logarithm, you what? It turns to division. So from there, that means this same expression here also equals 1 over 2a logarithm of x minus a over x plus a. Plus c. And always remember, always put bar here, which means magnitude. It means the magnitude of the what? Of expression here. So always put this bar here to make it complete. So that is how we got the what? The formula for what? For this. So in that case, I'll be doing a class of examples on same function we applied there. So example 1, what is the integral of the x over x squared minus 49? What will be our answer? Our answer will be x over x squared minus square root of 49 squared, and that gives us x squared minus okay, so in that case, to avoid any mistake, my a here will be equals to what? The square root of 49, and that is what? That is 7. So that means this integral here is the same as the integral of x squared minus 7 squared. In going from that to here, my answer will be equals to 1 over 2 times 7. Natural logarithm of x minus 7 over x plus 7. And that will be my final answer on this. So this equals to this. Second question will be the integral of the x over x squared minus 16. And that becomes the x over x squared minus square root of 16 squared. My a here in that case will be the square root of 16, and that is what? 4. In that case, the integral of the x over x squared minus 16 is equals to 1 over 2 times 4. Natural logarithm of x minus 4 over x plus 4 plus a constant c. That will be my final answer on this question. So the answer is equals to what? Is equals to this. The third example I'll be doing will be a quadratic expression that leads to this exact form. So in that case, if I have the x over x squared plus 10x plus 10x minus 20. That is, what should be here? So this leads to the x over x squared. So what we do here is you want to try to make the quadratic expression a perfect square. This is x squared plus 10x minus 20. Yeah? So what I can do here is I make this a perfect square. Now what is this? This is 10. And you know, in a quadratic expression, you have A, B, C. So this is your A and this is your B. When you are looking at a perfect square, you make sure there is no coefficient in the x squared. Alright, and since there's no coefficient here, you can go to the next step. The next step is looking for the half of this and squaring it. We have 10 here. So 10, half of 10 is what? Is 5. That means I'll put square on that, 5 squared. So that means here becomes 10x plus 5 squared minus 5 squared minus 20. And that equals the integral of the x squared. Yeah, so we have x and 5 here, and that becomes x plus 5 all squared. That's it. I take the x here and 5 here, that becomes x plus 5 squared. Here I have a minus 25 here, and I have a minus 20 here. Like it was the x over x plus 5 all squared minus 45. In that case, that becomes x plus 5 all squared minus the square root of 45 all squared. That becomes the form of x squared minus x squared. So my final answer here, so my A here will be what? Will be the square root of 45. Mind you, the square root of 45 is not a perfect square. It's not a perfect number. So in that case, you can't find the square root of a perfect square. So what I'll do here is my final answer will be 1 over twice of the square root of 45 natural logarithm of x plus 5 minus the square root of 45 over the x plus 5 plus the square root of 45. Have my final answer. So why did I put my x plus 5 here? This is actual reason. The x plus 5 here looks like an x, just like a single x. So you have x plus 5 here. It's a single x minus a. The formula is x minus a. So my x here is x plus 5, x minus a over x plus a. And I'll put my final constant. And that will be my final answer on the question. So that will be the video on integral of this form. And I'll be doing other exciting special form of integrals that are very difficult for students. So, and before I go, please subscribe to my channel and try to share the videos among your friends. And also, I would like you to give a comment on certain special integrals you would like me to do, so I can be dropping videos on that too.